I'd like to start this series off with a quick little exploration of camera 2D behavior versus camera 3D behavior when using Unity 3D. Now, of course, Unity is a 3D game engine. It's even right there in its name. So even when we tell our cameras to behave in a 2D fashion, we're still working in a 3D environment. It still gives us the results we want, though, in 2D. And actually, there's a lot of advantages by having the 3D stuff, like you get full access to physics, makes things really easy for you in so many ways. So I'm going to be showing a lot of the examples throughout the rest of the series in 3D, and I wanted to make sure that those of you who are going to be working a lot or exclusively in 2D have the reference point of what 2D camera setup is like. So as you go through the 3D examples, it's going to make perfect sense. Everything I show you is going to work equally well and equally easy in 2D. In fact, a little easier because you get to skip one of the dimensions. We'll use X, Y, and for the most part, you're not going to use Z. Use it a little bit for depth, but I'll show you here in a second. So let's get right into it and take a peek, and I'll show you how to set up cameras to behave in a 2D fashion inside of Unity 3D. In my hierarchy, I already have a camera. It's the one that comes in by default when you set up a new scene. So I'm going to go ahead and leave it in and work with that. And you'll notice that it's pointing down the positive Z when it's set up by default. And I'm going to leave it set up like this. So that way, when we work with objects and cameras in this 2D perspective, we're going to move the X left and right across the screen. We're going to use the Y to move up and down across the screen. Okay. The Z will be used very little, but for every particular thing I'll show you in a moment. So let me set the camera at exactly 000 world center. And if I make a cube, come up, choose create other cube. And I believe it got created out here in the middle of nowhere. So let me also set that to 0. And we'll zoom back in on it. Whoops, I said that, sorry. Come here. So now we have our cube and our camera kind of existing in the same spot. If I once again choose this camera and get my little preview and move backwards, I got the camera preview showing the cube right here. Okay, and let me just really quick throw, let's see. This will be fine. Throw a texture on it so that you can see it a little better. Camera preview's right there. That's what it looks like if we run the game. And if I duplicate this cube, move it to the side, and let's make it, put it exactly, say -3. Oops, -3 to the side. I'll scale it up, be twice as big, and let's change its texture really quick just so you can see it differently. Make that one red. Once again, selecting the camera. Now, important thing going on here. This is what you call a perspective camera. And you can kind of see in the little preview, and I'll do some zoom shots, you never really get a full flat view, right? We're getting a perspective view pointing there towards the middle. Like there's a point somewhere way, way off right here, and all of these lines are pointing down towards it. And as we move, that perspective will shift. So it gets more dramatic farther on the edge of a screen it is. So here it looks flat, but now this is way not flat, right? It's really exaggerated. And if you move this over so you get the red cube to look flat, the one on the right is going to get very exaggerated because it's using perspective. And this is all coming because we've told the camera to behave in a perspective manner. We can set things like field of view. It adjusts it a little bit, but still we're either exaggerating, like there I've just exaggerated the field of view. We can clamp it down and make it, say, a field of view of 30, which is pretty extreme. And if I pull back, it's going to seem like, if I pull way, way, way back like that, then I've kind of flattened out the objects more, but still not completely, and I've just made them small. So it didn't really solve my problem of being able to, want to see these things really close and have them be pretty flat like a 2D object. Like let's say you were going to map game sprites to these. You had little characters running. Well, this would look goofy if something odd were going on. And in reality, you wouldn't use cubes, you'd use a flat plane. But speaking of a plane, let's go ahead and throw in one of those. I'm going to create other plane, and I'll rotate it up, fix it numerically. So let's say, gives me my plane, and I'll set that to be world 02. So it's balanced. And you have the situation here where looking through the camera, you get all three of these objects, right, being shown moving in this kind of parallax view. You get some interesting motion if you move this, like, say, way back. And you move here. If you've never heard of something called parallax, this is what it is right here. These objects, because they're farther away from each other, seem to be moving at different speeds. See how the you see in that little preview window as the little cubes seem to move faster than the big one. It's because they're closer to the camera. And this effect is called parallax. Add to that issue of, like, if you're trying to flatten these out for 2D sprites, and you had some, like, this, say this was a tree card or a city background or something, a fence or things that you wanted your little characters and other objects in your 2D game to be passing in front of and behind, you're going to get this parallax effect, which is really cool. Really helps show motion and makes your scene look alive, but it's also next to impossible to get things to be flat. Let's take a look at how you would do that. Now, this, of course, is just regular 3D camera. This is the kind of behavior you want if you're making a third-person, first-person shooter, if you're making a racing game where your camera's going to be following a car. You want the buildings to make this kind of effect as you go by. But working in 2D, I'll go ahead and set this back to 60 just for good measure. We're going to change our perspective here. Once again, I've got the camera selected. I'm going to change the projection from perspective to orthographic. Watch what happens. Totally flattens out, okay? And suddenly, moving this doesn't have the same effect at all. If I play, look, they're way off in the distance. And you'll see the size has appeared. When it's on perspective, it's field of view that you get to adjust on the camera. When you switch to orthographic, it says size. And this means the camera size. If I make it 50, you see stuff gets a little closer. Make it 25, it gets closer yet. Let's just go all the way down to, say, 5. Now, look, I'm bringing my objects closer, and they're really, really flat because we are rendering things perfectly parallel, okay? So we've got this long kind of box-shaped frustrum now that we're rendering. No longer parallel. Perspective, get this nice kind of conic shape, shaped like a big cone, and so it's giving you that different perspective. Orthographic, it's very square. Everything is rendered parallel. So that's what gives you this effect. If I come in, make the camera size 2, so really, really close. Look at how these boxes look. Absolutely square, just like you'd expect a sprite to be. And again, in reality, you wouldn't use a cube to map this on, because if you can't see the back part, you're just wasting all this. You'd just use this one face, like a plane like this. And I would recommend not using the Unity plane, because look at all this geometry. It's fine for a big terrain start point or a lot of physics, but if you just want one sprite on it, you just need one polygon. So I'd suggest make one in your 3D program. Just bring in one plain square poly and use that in place here. But these cubes will work because I want you to see what's going on in 3D too as I describe this process. So the camera can still move left and right. Okay, you see in my little camera preview, as I move the camera left and right, the objects still pan left and right, just like you'd expect. If I move it up and down, they move like that. But look what happens if I move Z. Nothing. Nothing at all is happening, because we're no longer setting the depth of these objects, the size of these objects, the same way we were before. Because if you remember, perspective, we moved in and out. See, they come in and out, closer and farther away from the camera. Just like you're holding a camera and you step closer and farther away to some cardboard box or building, you're going to get that effect. Orthographic, it's not the same. What we're doing with the Z depth here is really more like how Photoshop or Pixelmator or Illustrator, any of these image editing programs renders layers. We're really talking about what's rendered in front of something else. So if I bring this object in front, and you look, it's now in front of the other one. If I move it behind, it's now rendering behind it, just like you'd expect, because if you look down it, you can't see that. Okay, so it kind of makes perfect sense what gets rendered and what doesn't in front. By the same right, if you look here, this big gray thing is our background. Actually, let me throw a reference texture on there so we get a little bit of something. You can now see this is a 512 by 512 texture I have tiled on here, I think 20 times. You can see it independently, but if I bring it forward, let's look really close. Here it is, okay, and we're still looking at the front part of this. Look through our preview, pretty much the same as it did before, right? We haven't scaled anything up. These are still, there's still roughly like 2 boxes in between the two of them. If I move that, say, way back here, way back here, let's look again. Look, still looks to be the same size. It's nice and flat. All we're doing is deciding what gets drawn on top of what else. If I move this in front of that box, it draws in front of that box, but it still appears to be the same size. When you're working in this orthographic view, the Z position of your objects in 3D space is really just the draw order. What do I draw on top of something else? Okay. That is an important thing to keep in mind there. Let's talk about size and how do you set up the size to get anything at all useful when you look through the game window. Well, first of all, I'm going to pick in the game a particular size. Let's choose iPhone wide 480 by 320. So this is now 480 pixels this way, 320 pixels this way. And we go back to scene view and set our camera in the inspector. Our camera size, let's set it to 1. Okay. Look at the game. And what happens is the size is showing 1 unit, okay, roughly 1 unit from the middle up. So essentially, the size is half of what's going to be displayed on the screen. So in other words, if you start in the middle section of the screen, middle of the side, middle of the top, you get exact world 000, then you're going to have a value of 1, which is the size from the middle to the top. So let's look at that with something we know the size of. This is a 1 unit cube, okay? So let's set it to world 000. And if we set the camera back to 000, so everything is lined up. Well, we'll leave this at -5 actually, so it's far enough back. We set it to -0, the cube pops away because the cube is now behind the camera, so it wouldn't work. So we'll leave that at -5. Make sure we get a draw order. And let's look. So size of 1, right? This is exactly half the size of the screen because 1 unit cube is half the size. In other words, from the middle of the screen to the top is 1. Let's set this to half. 0.5 is the camera size. And as you can see, it filled. So now when we look at it, full screen, 1 unit is the full size. Okay. If we back this off, it's going to follow the same math. So if we double the size of the camera, the cube is now half. The 1 unit cube is now half of the 2 unit screen. If we make the size 2, stands to reason that the cube should be 4 units, right? We're starting to get this relative scale here. So you can see how that grows and shrinks. Now, once again, let's think about it in terms of pixels. We now know we're talking about units off. And actually, I don't think I have this set up right to really show. Yeah, see, this is all over the place too. We'll leave that at 6 so it renders correctly, but let's center it. And this is actually set to a different scale. So the Unity plane comes in off. Whoops. And we don't actually have to set that one. So now it matches the size of the cube. It's actually 0.1, 0.1. So that's what's going on with the size of that one. It's a different size, so you can't really get the same relative. That's why these 1 units are not matching with the cube. So that's why I'm showing you that cube. Let's get this one in the view too. Say it was at 0. So if we move it over so it's just a little off to the side, actually -2 would be fine. Nice and clean. And if we move the camera just to the left, you can now see clearly. There's our 2 unit reference, there's our 1 unit reference. So works nicely. What we have is, if you remember, 480 pixels by 320 pixels. So that means if this texture mapped right on here could be 320 pixels by 320 pixels, exactly square to fit that cube in there. This one would be half that size. So half of 320 would be 160 by 160 pixels. That's the size of this. So if you wanted to match your pixel, or sorry, your texture to be exactly the same number of pixels as the object that it will be mapped on and display on screen, that would give you a 1-to-1 relationship. That would give you the least distortion of your texture. This is how you would figure out how big that was. And you can keep shrinking and growing these elements to be the size you need. Here we've doubled it. If it's now, see, once more, we were half the size. So what we had was 160. So if we double the camera, that would half the size of this object, which would make it 80. We double it again, we're now down to 40. And you could just assume this is going to be a 40, well, you don't assume, you know, this is a 40 pixel by 40 pixel texture. So if this is the size you wanted your objects to appear on screen, you know, this is 40 by 40, this would be 80 by 80. So you can do this math and give and take, figure out how big you need your objects on screen, how big you want your camera size to be to match all that, and know what size you should make your textures so that you get no wasted, no wasted fill time, no wasted pixels being converted down. You're not loading too big of a texture into memory. You're not using all those issues that come up. And depending on what you're doing, there's going to be slightly different approaches to it that you'll need to fiddle with. But this is how you approach dealing with that. Okay, now the last thing I want to talk about here with the 2D cameras is you can see the frustrum here, which is represented by this box. Frustrum just means the area that will be rendered in by the camera. It's just a fancy way to say that. It goes off quite a distance, and that's because we have the far value set to 1,000. So far means how far away from me, how many units does it go, and near means how near does it start. That would be this side. And as you can see, it starts at 0.3. So essentially, you look here, it's right in front of the camera, pretty much just instantly in front of it. You set that to be, say, 5. Now see, it doesn't start rendering until in front of the camera. If you remember, the camera is set to a -5. These are set to 0, 0. So at 4, these show up inside of it. If we set that to 6, they're outside of the frustrum, and look, they no longer render. When you're moving the frustrum around, that's really what you're doing, is deciding what gets rendered and what doesn't. By the same right, if these are 0, what do we set this at? 6. So if it's 5 from here to here and 6 from here to here, that's 11. If we wanted to match the far frustrum up to here with the camera selected, we could say, if we set it to 7, let's say 12, the distance was 11. There we go. It's just past this background plane. So it's going to render that background plane. If we set it to 10, which would be 1 unit in front, there it is. It's right in front of the background plane. It's outside the frustrum. It's no longer getting rendered. And as you can see, that's what's going on there. It's a way for you to specify what gets rendered and what doesn't. And it's not something you're going to fiddle with as you play the game. It's something you're going to set up and know, that you can bring objects in and out of the frustrum, know how to place things. It's just something you set up. This is the same sort of thing that works with, say, if you use fog in a game, anything along those lines. Ray casting too. If you do a ray cast to see how deep should I go in to hit an object, then that's the same sort of thing. You're just deciding how far out you're going to go with your frustrum. And of course, the less you have to check for, the more performance you're going to get. There you go. That is the basics of how to set up a camera to give you a 2D look and feel. You can see, you look in the little preview, moving around, and you can have your characters moving or doing whatever they're going to do, and things are really good. All you do is move on the X and the Y. Okay, you don't animate your characters or your objects or anything in the Z. You only do that to position whether they render in front of or not. Like if this were a building and this red box were a building, this were a character, you'd walk them in front. You'd animate it that way. That's how you'd make that work. Otherwise, it works just like 3D cameras. All the objects are still 3D objects. Physics is still calculated in 3D. The cameras can still be animated that way. Everything works the same. So with that overview, let's go ahead and dig into some of the camera-specific stuff in Playmaker.